Now let us discuss another problem from NMR. Here the question is to determine the chemical shift. The question is to determine the chemical shift in ppm. Whenever it is required to find in ppm, please remember that you have to multiply it by 10 raised to 6. Now what is the formula for chemical shift? We have seen chemical shift delta, this is equal to new sample minus new reference divided by operating frequency. If you require your answer in ppm, parts per million, then you have to multiply this by 10 raised to 6. This is very important. You have to remember this. If you are required to find out the answer in ppm, then please multiply your result by 10 raised to 6. This is the general formula for chemical shift. That is, to determine the chemical shift, first of all, we need to find out the operating frequency nu 0. We can say that this is delta, this is equal to new sample minus new reference by some nu 0. So we have to find out the operating frequency. How the operating frequency is determined? When the transition took place, the transition happens when the energy of the radio frequency wave is equal to Gn mu n B0. This is the condition for resonance. That is, at a resonance, your h nu or h nu 0, this is equal to Gn mu n and B0. So first use the resonance condition to find out nu 0. Nu 0 equal to Gn mu n B0 by h. Here also the nuclear magnetone is not given, so you have to remember the value as in the previous problem. The value is 5.05 08 into 10 raised to minus 27 joule per Tesla. Okay. So and also here one more thing you needed, that is the value of Gn, that is nuclear G factor. The value is 5.585. This is also not given the question, so you need to know these two parameter that is the value of nuclear magnetone and the value of the G factor for the nucleus. And knowing these things, you can calculate nu 0, that is Gn 5.585 into mu n. Mu n is a nuclear magnetone, this thing. Then the field B0 divided by Planck constant. So you will obtain the frequency as 7.0245 into 10 raised to 7. So this thing is obtained. Now in the present case, the reference sample is tetramethyl silane. So it is abbreviated as TMS. So I can write V reference equal to V TMS. So delta, the chemical shift delta becomes new sample minus new TMS divided by the operating frequency nu 0, it is nothing but 7.0245 into 10 raised to 7. In the question, the separation between protons in benzene and TMS is 510 Hertz is given. That means the difference new sample minus new TMS is given. The shift is given new sample minus new TMS is given. What is the value? It is 510 Hertz. That is 510 Hertz. So the delta will become 510 by 7.0245 into 10 raised to 7. But we need the answer in ppm, so please multiply this quantity by 10 raised to 6 and your answer is 7.26 parts per million.